Motors that work by turning molecules. What is the meaning of thermal energy and the method of heat transfer from one body to another and the effect of heat on the volume and pressure of different gases that lead to work events in the engine? With an explanation of some chemical equations in a simple way to help understand the changes that occur to fuel when it is burned. How does this result in a certain amount of heat, with an explanation of some necessary technical expressions, such as absolute pressure, standard pressure, air-to-fuel ratio, and the upper and lower calorific value. First, what is heat? We have defined heat as a type of energy, which is the kinetic energy of the small particles that make up matter, and they are in a state of transition from one body to another because of their different temperatures. These particles are in constant motion in various directions within the matter, whether gaseous, liquid, or solid. And if a body gains heat, this means providing its particles with an energy that works to increase their speed, and accordingly its temperature increases. While solids maintain their external forms, one of the properties of gases is that they are fluid, taking the shape of the containers they contain, and their constantly moving particles strike at high speed on the walls of those containers with a certain force that can be measured and is called gas pressure. Limited, such as a closed container, for example, this heat increases the intensity of the gas particles knocking on the walls of the container as a result of the increase in the speed of their movement, and accordingly the gas pressure increase. This is what happens when the fuel burns in the cylinder of the internal combustion engine, because the combustion of the fuel gives an amount of heat to the gases present at that time in the limited space called the combustion chamber, and thus the temperature of these gases rises and their pressure increases, which in turn affects the walls surrounding it. And since the upper surface of the piston is one of these walls, as it is the only movable one, pushes downward, leading to that effective stroke, and during its descent, the volume of gases increases, meaning that it expands. Heat flow. The study of engines usually requires attention to the flow of heat through them. The amount of heat gained by a body is estimated in terms of the increase in its temperature. The heat that it loses is estimated in terms of the decrease in its temperature. The unit of the amount of heat is kilocalories. Materials differ from each other in terms of the amount of heat required to raise the temperature of a specific mass, including 1 degree Celsius. For example, the amount of heat required to raise the temperature of a specific mass of iron by 1 degree Celsius is approximately 1/8 of the amount of heat required to raise the temperature of the same mass of water. 1 degree also, and this is due to the fact that each substance has a specific thermal property called specific heat, and it differs in value from one substance to another. Specific heat. The specific heat of any substance is the ratio between the amount of heat needed to raise the temperature of a specific mass of which 1 degree Celsius to the amount of heat needed to raise the temperature of the same mass of water by 1 degree also. The table shows the specific heat values of some minerals and gases that are related to internal combustion engines. The specific heat of a gas differs if its pressure is fixed or its volume is fixed when the heat flows into or from it. The value of the correct unit for the specific heat of water has been taken according to its aforementioned definition, because a kilogram of water needs a kilogram of calories to raise its temperature by 1 degree Celsius. Thus, it can be said that the specific heat of any substance is the amount of heat estimated in kilocalories, which is necessary to raise the temperature of 1 kilogram of it by 1 degree Celsius. From the temperature D1m. So the amount of heat equals mass of matter x specific heat x change in temperature. Or free equals kx mx, d2, d1. Example. Find the amount of heat required to raise the temperature of 50 liters of lubricating oil from 20 OC to 80 OC. If its specific heat equals 0.05 kcal/gm and its density equals 0.92, equals 0,92. So equals 0.92, meaning that the mass of a liter of oil equals 0.92. And the mass of 50 liters of oil equals 0.92 x 50 equals 46 kilograms. So the amount of heat required equals kx mx, d2, d1. Equals 46x 0.5x, 80 to 20, equals 1380 kilocalories. Heat transfer. Heat flows or transfers in the following three ways: conduction, radiation, pregnancy. Conduction refers to how heat flows when a body with a high temperature touches another body with a low temperature. This may happen inside a single body when the temperature of its parts differs from one another. Radiation means the flow of heat from a hot body to a cold one without them touching. Convection is the way heat flows from one body to another through a third body that carries heat with it. Gas pressure and volume. To study internal combustion engines, we need in the first place to know everything related to dealing with gases. The air that is compressed inside all types of internal combustion engines is nothing but a mixture of gases. The fuel burns and forms hot gases that expand in turn so that we get the necessary work to run the engine, whether it is the piston in the reciprocating engine or the turbine in the jet engines, then they are expelled outside the engine. Therefore, it is necessary to expand the knowledge, understanding, and summarization of the general properties of gases. This is if we really want to develop it, as well as understand and study how the motors work with the current fuel. And what can we do to adapt the motors of movement to the types of fuel that we hope to reach in order to provide new and safe types of fuel. Gas pressure. One of the natural properties of gases is that they always have a certain pressure, as their molecules are always moving in various directions and pressing on the walls of the containers that contain them. Gas pressure is usually measured either in kiloponds per square centimeter, Liv/cm2, and as for the height of a column of a certain liquid such as water or mercury, the pressure of the gas is equalized. The pressure of 1 kilopond per square centimeter equals the pressure of a column of water whose height is 1000 centimeters and its base area is 1 square centimeter. The volume of a cube of water whose side length is 1 centimeter equals 1 cubic centimeter. Weight of a cube of water of side length 1 centimeter equals 1 g. So a column of water has a base area of 1 centimeter and a height of 1000 centimeters equals 1000 weight cm equals 1 kilopond. But if the column is made of mercury instead of water, then its height is much less than the height of water, because the weight of the first is 13.6 times the weight of the second. Accordingly, the height of the column of mercury, whose base is 1 square centimeter, represents a pressure equal to 1 Liv/cm2 equals 73.6 centimeters. Example. When using a pressure gauge to measure the pressure of the exhaust gases coming out of a four-wheel drive, it was found that the pressure is 20 centimeters of water. Find the amount of this pressure estimated in units of Liv/cm2, then estimated by the height of a column of mercury. Exhaust gas pressure equals 20 centimeters of water equals 0.02 Liv/cm2. Equals x 73.6 equals 1.472 centimeters of mercury. Gas volume. The volume of a gas is the space it occupies inside the container it contains. Accordingly, the volume of gases in the cylinder of a reciprocating engine changes according to the position of the piston inside the cylinder. The volume decreases when the piston ascends during the compression stroke, and the gases are then in a state of compression. The volume also increases when the piston descends during the active stroke. The gases are in the state of expansion. Gas laws. The three directly measurable properties of gas, volume, pressure, and temperature, are related by the following simple law. ZH equals kBe. Where Z equals absolute pressure of the gas in units of kPa/m2. H equals volume of gas in m3 units. K equals mass of gas in kg units. B equals a fixed and known number for each gas, and it is called the characteristic constant of the gas, and its value in the case of air equals 29.3. E equals absolute temperature of the gas. By means of this law, a specific mass of gas can be found if its volume, pressure, and temperature are known. It was derived from the previous law, the three simple rules that help to estimate the change that occurs in one of the properties of a certain amount of gas if it changes in another. First rule. The volume of a gas is directly proportional to its absolute temperature if it expands or contracts under constant pressure. The second rule. The change in the pressure of a gas is directly proportional to the change in its absolute temperature if the volume is constant during this change. Third rule. The change in the volume of a gas is inversely proportional to the change in its pressure if its temperature is constant during this change. Application results of the laws of thermodynamics. Heat engine. A heat, thermal, engine is a machine that converts thermal energy from natural energy sources such as chemical or nuclear fuels, solar energy, etc. into mechanical energy in a useful way. Historical overview. The development of the heat engine from its initial form, which originated in the 18th century. From the steam machine operating on the potential energy of the steam heated in a boiler and directed to a piston engine, to obtain mechanical work, and then to engines operating on oil derivatives such as the Otto engine and the diesel engine. Then the turbine, jet, rocket, and rotary engines appeared. Until the end of the 20th century, new forms were designed for most of these heat engines, which were characterized by good work efficiency and higher fuel economy. In addition to making strenuous efforts to obtain low pollution rates for fuel combustion processes in them, through advanced electronic control in organizing their work and accurate calibration of fuel flow, widely used in various sectors of mechanical strength. The structure of the heat engine and its working principle. The heat engine generally consists of a fuel and air supply system and a system for igniting their mixture in a special combustion chamber. For the working gas mixture, or what is called a working medium substance that carries the thermal energy liberated from fuel combustion, and the engine body with the mechanical design of the method of machine performance, which is the one that the heat return N is determined by the ratio of the useful work W done to the heat energy Q given by the hot source. The good efficiency of the heat engine cycle is generally achieved by increasing the compression ratio, accelerating the combustion process, and reducing the heat loss leaking from the engine body to the outside environment. The work of all types of mechanical heat engines includes four basic operations: compression, obtaining heat as a result of fuel combustion; expansion and performing useful work; then expelling the remaining unused heat-bearing combustion gases to the outside environment, downstream. The thermal cycle of a diesel engine. Thermal cycle of a gas turbine internal combustion engine. Thermal cycle of a turbine steam engine with a condenser. The concept of the thermal cycle. The thermal cycle is a set of operations that take place inside the cylinder in a specific order, with the aim of converting the thermal energy of a charge of fuel into kinetic energy, work. The thermal cycle may be 2 or 4-stroke rides, where in the 4-stroke cycle the piston moves 4 times during 2 turns of the crankshaft, while in the 2-stroke cycle the piston moves only 2 trips during 1 revolution of the crankshaft. First, the motors that operate on the Otto cycle, automotive engines. And this will be the content of the next video.
Do not forget to subscribe to the channel to receive what we hope will be useful. Follow us.